How you all doing? First day of Next, right? First event in person in a few years, so I guess we're all excited and pumped to be here today. Um, so, if you look under your seats, you're not gonna find anything. So sorry, I gotta make that joke. It kind of tells my age, right? Well, I'm Adrian Corona. I'm the go-to-market lead for security solutions here at Google Cloud. Super happy and thrilled to be here with you today. Today I'm going to tell you a little bit about Security Foundation, which is Google's perspective on security workloads, on running security for cloud workloads. But joining me today, or later today, we're going to have a great panel with our friends from Mayo Clinic and Google Cloud Services. And last but not least, we're going to leave some time for traditional Q&A. I will ask you if you have questions to ask, please come up to the microphone so everybody can hear your questions, and your lovely voice will be recorded for posterity on the recorded sessions in YouTube, so you'll have that going on for you guys. All right, let's get going. So let's start a little bit of a brief overview of what Security Foundation is. It's no secret, pretty much every organization in the planet is using cloud in one way or another, and it's growing at scale. Very significant rate, and security is a very important, it's a primary concern for all of our customers and all of our users. There's new threats coming in every single day, and now we've seen that more and more, we see those researches and malicious things being posted very quickly, and they're made available to pretty much anyone to use and attack your beloved networks, and they're being released at a very alarming rate. We also have cloud compliance. If you're in this room, you probably care about security for your cloud. You run some cloud program in your companies or organizations, and you most likely care about compliance, right? So we all, I guess the way I want to put it is, when we think about cloud compliance, is we all want to be not in the news or not be the next one, or even worse, in jail, right? So compliance is a big deal for everybody. A very common question when I speak to customers is, they ask me, Adrian, is my cloud secure? I think that the line of questioning needs to change a little bit more into, am I using the cloud securely, right? I know it sounds subtle, but what does that mean? I'm sure that most of you here know that about the shared responsibility model when you talk about cloud, right? Which is basically splitting the responsibilities from a cloud provider or the cloud management to the CSP and what the customer needs to be doing. That is a model that pretty much works, and it has its advantages, but in some situations leaves our customers at, they have to make decisions that may or may not be very well informed about. Like, hey, maybe I'm coming in from a new cloud that I don't know about, and I don't know what controls, the security controls or offerings you're giving me, or maybe I'm new to the cloud altogether, so I really don't know what's going on for me. So Google understands this, and we're trying to be an ally for you. What does that mean? So we're creating a number of things, assets, to make it simple for you to start in the cloud. We try to be there at every step of the way. And what does that mean? If we have different programs, I recommend it's not part of this conversation, but if you look into and Google the risk protection program, for example, is one of the things we've done as Google to really put our money where the mouth is. With Security Foundation, we created this type of program to help customers to get ramped up on security through a list of assets that you can use to manage your security. Those assets come in the name of blueprints, Terraform scripts, so you can build a security landing zone. But this is great. A secure landing zone is great if you are new to the cloud or you're just building something from the ground up. But not only for that, like some of these assets and some of these white papers are also going to be helpful if you're already running a cloud practice and you just want to make sure that your security is running, if you're running your cloud securely. Remember that first thing that I mentioned. The components that we focus on are things like network security, monitoring, malware, those type of things that we know that are important for all of our customers. All of you probably care about those things when you're talking about cloud security. But now, the way we did it is we try to do it a little bit different. We're not just trying to push product. We're not just going to come in and tell you, hey, this product does this, this is the capabilities. We kind of took a step back and tried to make a list of what are the most common scenarios that customers run in the cloud. So we have a short list. After that short list, we sort of analyzed that list and said, okay, what are some of the most common security risks that we see associated with these things? So we think like, we map those risks to each one of these use cases. And for example, I can tell you if you're running Secure AI, which by the way, it would not be a conference if I don't say AI and somewhere, I don't put, wait, I had to make my quota for AI today, so that's me making that money. But like, think about it, like I'm building a new LLM model, and I want to make sure that there's no data leakage or data exfiltration by a malicious actor trying to just trick my language model into giving me proprietary information from it. So how do you do that? There's some tools that can help you with that. So those are risks that are common. Or if you're just a traditional lift and shift, data center migration, you're bringing in some VMs into cloud, well, you're probably going to care about OS vulnerabilities, misconfigurations, my networking, firewalls, that kind of stuff, right? Now let's think about a sample architecture of what we offer. So I mentioned Security Foundations is a set of assets that are at your disposal to start getting started, right? To give you that foundation. If you're building a house, we're going to give you some things like, here's the foundation, here's the type of windows that you need, here's the types of security devices that you need to protect your house, right? Or if it's a building, well, maybe we're going to tell you that as well. This is a very sample, one of the sample architectures for one of our solutions where we talk about modern application security. There's a few more based on the use cases that I already spoke about. And for example, here, we're trying to solve for 3 major problems. Protecting the integrity of your code, protecting the integrity of your data, and making sure that your application's perimeter is also protected. So with that, we have like 3 major things. I'm thinking about from the bottom up access. We have some tools like Cloud IAM. Thinking about like, I'm protecting the provenance of not only my customers, but also the developers that get access to the data that's underlying on my application. Through identity-aware proxy and Cloud IAM, I can provide those front-end identity services to my application. The second one is supply chain. I know supply chain it's a topic in itself, so I'm not going to go too deep into it. We created frameworks like Salsa, for example, and we have our software delivery shield with some capabilities that can help you to build secure code. But also we have things like artifact registry and artifact analysis it's going to look into the actual code and containers, and it's going to look for vulnerabilities as you're building your application in a traditional CI/CD pipeline. So as you can see in here, things like binary authorization. Just quick raise of hands, how many of you have heard about binary authorization? Okay, that's a good number, but still low, I would say. Binary authorization is super cool. I would strongly suggest you to do a little bit more research. I put some information here in the slides for you to look at, but that's what Google uses to make sure that binary authorization enables you to do an enforcement and auditing to ensure that only known binaries can be run in your environment. And all that is done through certificates and attestations that are cryptographically verified. So why is this important? Like here at Google, we can pretty much identify any single binary that is running YouTube or any of our services, and we can tie that up specifically to an individual because that's signed with that binary is signed with that individual's key. So you can expand this. This is something that we use, and Google does that a lot. We create things to run our stuff, and from there, we just make it a product for everybody to enjoy. So binary authorization is one of those things that's going to help you with your supply chain, because even if at some point you get some code inserted into your platform, you're going to be able to understand, and the binary is going to be different, so you're not going to run that particular application because it's not authorized to do so. And last but not least, we have compliance, right? So we care about compliance and runtime. So runtime, Security Command Center, Web Security Scanner is going to look at your application's code, and it's going to try to identify vulnerabilities for it. And it's also going to look into the compliance of your application and your cloud posture. So it's going to tell you things like, hey, you probably have this role or this user that has a lot of different roles that are not likely or are a little bit too much of what's needed for this particular user. Or things like Cloud Armor. When you think about the perimeter, Cloud Armor is one of my dearly beloved products because it's sitting on top of the same architecture that Google is using to run protection for our services. Like, think about how many DDoS attacks we get in YouTube and Gmail every single day, right? So CloudArmor is using that same infrastructure. And what it's doing is helping you to protect from a layer 7 type of attacks. If you're curious about it, you can read our blog post and how CloudArmor was able to thwart the largest DDoS attack in the history of mankind. It was like 46 million requests per second, and we were just easily able to do so. So imagine you having that power just by including CloudArmor as part of your architecture. Now, this is security foundations. There's a lot more. Google has a gigantic security portfolio, but foundationally, these are some of the things that we believe that are the very minimum things that you need to run your stuff securely. Part of the assets that we provide, again, Terraform scripts to deploy a POC very quickly, white papers where you can see and read and understand what each of these components do. It's available to you at no cost. But I want to say that don't just take my word for granted. Right now, what I want to do is I want to invite Wade Holmes, my dear friend, to man the panel here with our friends from Mayo Clinic and PSO Services, or Google Professional Services, and they're going to tell you a little bit more about how they did it in real life, and they're going to tell you about their story and their journey. So please welcome Wade and team.
All right, awesome. Thank you, Adrian. Good afternoon, everyone. Let me start off with a couple intros. My name is Wade Holmes, and I'm the global lead of security solution management within Google Cloud, and excited to be here with my friend, Dhananjay. Go ahead.
So I'm John Stricker. I'm the lead software engineer for the Neurology AI program at the Mayo Clinic.
I'm Dhananjay Dalave. I'm strategic cloud engineer at Google. I'm part of GCAT and from security and compliance team.
So here at Google Cloud, we're extremely passionate about working with our customers, with partners, to make sure that we're able to provide a secure infrastructure. And being able to do so is not only about being able to provide products and product capabilities, but it's also about being able to increase the business agility of our customers by being able to ensure security is baked into their architecture in the right way. So I'm super excited to hear about John's story and the journey that Mayo Clinic has gone on, and also to be able to talk to Dhananjay and talk about how services have helped John and Mayo Clinic down this journey. So John, tell me a little bit about that journey.
Yeah, sure. So first, I'm going to tell you a little bit about the Neurology AI program. So in the next slide, you'll see that we're an interdisciplinary team. Our general approach is that you need to have information technology, data scientists, and clinical expertise all on the same team working together to solve problems. We're a clinically applied group, meaning in all of our work, our research is all about clinical applications direct. It's not about translational. So on the next slide, I can tell you our general mission is what we want to do is modernize the neurological exam. We want to take AI analysis and we want to be able to display the results of those analyses to neurologists in ways that they can use to help them train, help them give feedback to their patients, help them diagnose patients. So here you see state of the art at Mayo Clinic. Here's what our director, David Jones, does when he's doing training. You need to have a lot of slides. You need to be able to make comparisons between different brain scans to be able to indicate or to learn what are the differences here, because it's a bit of an art, not so much a science. We want to turn it into a science and make it directly applicable and usable inside and outside of Mayo Clinic. And on the next slide, you can see what that looks like now. This is State Viewer. This is our product that's running on Google Cloud inside Mayo Clinic right now. This takes AI network analysis, neighborhood network analysis. It lets you see how much alike is a given brain like another sort of brain. So you can see it provides a neighborhood analysis. You get a sense of spatial similarity between the brains. Neurologists have been using this not just to make the diagnosis in a system, but then to turn around and be able to discuss this with their patients. It's actually, they found it to be very useful to be able to say, your brain's a lot like this person's, and you can kind of see how the similarities are here. So this is an example of the kind of technology, and we're just getting started. So on the next slide, That's with FDG PET imaging as its core for state viewer, but we want to go across modalities. One of the other things we need to do, we need to get better data. So a lot of our cognitive tests, for example, are decades old. We need modern cognitive testing. We need to be able to have modern ways of collecting speech, gait, a lot of other things that are, a lot of other modalities that are also going to be useful and are part of the general neurological exam, but they also are usually very informal, or you have to go to a very specialized lab to get that data. So we are spinning up software applications that allow us to get cognitive testing. We're working towards modernizing gait analysis as well, and we also are working towards EEG data as well. We have this whole ecosystem. Eventually, the idea is we want to be able to go across modality too. So we might have FDG PET data and be able to say, well, your brain looks a lot like this, but it would help us out a whole lot if we could get some speech samples. Oh, by the way, here's a link. You can go and it'll, across the web, get speech samples for you. So then you can sort of like collapse across modalities and fill in the blanks, figure out what you need. So understandably, this is a pretty ambitious goal. And on the next slide, I want to talk a little bit about where we were a year ago. We already had State Viewer with FDG PET data, but we couldn't run it anywhere. We had developed the software. We did not know where we were going to put it. Mayo was doing some fair amount of work with Google Cloud, but we didn't see like a clear path towards being able to put this in production. We were working with PHI, and Mayo is obviously very, very sensitive about any sort of security risk as well, and we needed to move fast and be able to iterate in production. So we teamed up with our executive group, so Vish and Jim and Stacy, and other people from Mayo IT had already established some patterns, but I also said, we need a team, I need help. And that's when we got Google PSO involved, Dhananjay and Leica in particular, and they got on board with us and they got to work. So over the next year, we not only put State Viewer into production, but we put together basically a platform for all of our products. So I would have just been happy over a year ago to just have one thing running, but instead what we were able to do is set up basically a platform that allows us to easily put new products in and start to integrate them.
Oh, that is awesome, John. That is a very exciting story, and to tie in AI to be able to build a platform using secure Google Cloud services is very interesting. Can you talk a little bit more about some of the specific Google Cloud services that you used in this platform?
Yeah. So here's what we call our Google Cloud Run service pattern. So this is one thing that's helped us immensely. We have a lot of oversight internally, so we have technology assurance processes and things like that. One of the things that has helped us a lot is we have other groups like Cloud Application Factory and so forth. They get approved patterns. And so once you have those patterns approved, then you can start using them everywhere. Now, we're using a lot of managed services as well. So you'll see, Cloud Run. I love Cloud Run. Cloud Run is awesome. It's managed Kubernetes. We're able to deploy containers on there easily. But the other services like Secrets Manager, like Artifact Registry, what we do is for every Cloud Run server we have, they each get their own. These are really lightweight, and once we have the Terraform scripts to spin them up, we can easily spin them up. So we can basically take this pattern and just start putting it everywhere we want a server. And I'm going to show you in the next, I want to say one more thing. No, sorry, man. What you also see then above there is our control plane. So we have these services, these patterns that we can use, but then they will reach out to our control plane, and that's where we have things like binary authorization. So that's where we are able to we have some centralized things that we're doing for security as well. So when you have an established pattern like this, and then if you go to the next slide, you can take that pattern and apply it everywhere. So this is now our architecture for a Mayo test drive. This is our cognitive testing platform. You can see that we have the Cloud Run services in a whole lot of different places. And what it's allowed us to do is, I wouldn't call it micro services, but it allows us to take each of these Cloud Run servers and basically spin them up based on access needs. Who needs to do what with that server? We can just easily spin up this pattern for each of these different features. And then we can use things like identity aware proxy, and we have a pattern for using that, or we have session-based authentication if we have people that are outside of Mayo Clinic that are using it. So this results in, once we have this down as infrastructure as code with each of these patterns, they become these building blocks. And then we're just able to start fitting them in based upon our use cases.
That is awesome to be able to build these secure patterns and building blocks that are not only applicable for this application today, but potentially the future. So in building this, it was mentioned that you worked very closely with Google Cloud and services. So I'd love to hear, Dhananjay, how was services in Google Cloud part of this journey in helping Mayo Clinic?
Well, we designed many IAC pipelines and Terraform pipelines basically, but I would like to highlight few of the important security controls that we implemented because we had security requirements from Mayo security, right? So there are certain requirements where we wanted to enforce certain policies from the top down, and that to implement that we need to have the organization policies. So if you see in the diagram, right, we first designed our organization policies pipeline where we applied certain policies. We have over 50 organization policies applied on the top level folder, but I would like to highlight how we designed everything with just taking one example. So if you see there, we have one organization policy called run.allowed binary authorization policies. So as Adrian mentioned, like binary authorization, I don't need to explain what it is. So basically, by that policy, right, each cloud run under NEP folder needs to have binary authorization policy defined. So by that, we decided to design a central binary authorization control plane where we have all the images that are uploaded basically under products folder. So on the products folder, we have log sync, which triggers the event when there is any upload to the image in the artifact registry, and then it scans the image. It triggers the event to the workflow, and which triggers the critic signer, which signs the image, and then once it is signed, only signed image will be deployed to the cloud run. So as we have designed this central binary authorization policy to support our organization policy. Because if we just do the organization policy and binary authorization, we give it to products, basically you implement binary authorization, then security can be a pain, right? So we already defined central binary authorization control, basically by which all images will be signed if those meet the certain security criteria. Next thing is like basically we, as we see with the binary authorization, right? Like anyone who has a permission to deploy the cloud run, deploy the image on the cloud run, that person will be able to do the break the glass. So we have to design IAMs very carefully so that no one can deploy the image which is vulnerable, right? So as to do that, we have to do the CI/CD, because if we give a permission to developers to deploy, they can do the break the glass and they can just deploy the vulnerable image as well. So we designed the CI/CD pipeline where our cloud build deploys the image. No developer has a permission to deploy the image, but admins has a permission to deploy the image, so that we can governance the binary authorization where we can, if someone wants to deploy the vulnerable image because of certain business requirement, that needs to have a justification, and that can be done by admin, not by developers. So that way we designed IAM pipelines basically, and we defined IAM with respect to custom roles, very specific custom roles we designed and assigned at the project level only for a certain groups. So at the end, basically security is layered approach, right? So we have a VPC service control around all the projects that we have here, and then on top of that, like we have beyond corp context-aware access to securely give access to the users who needs to have access to the environment. And all this thing is done with the Terraform. We do not allow anyone to change the infrastructure directly on the from the console. Everything is in Terraform. Certain things like configuring IAP, IAP consent screen is not what we can do through the Terraform. So there are certain things are allowed for admins to do it, but everything is in Terraform. No one can change the infrastructure through console. So this is not just foundation, but this is the platform for rapid application development. Back to you, Ed.
Oh, that is awesome, and it's great to see the partnership between services and professional services in being able to utilize the capabilities of both our IAM platform, binary authorization, and VPC service controls to be able to create this secure microservices or secure microservices pattern. So, John, you mentioned that this is now something that is reusable. At Mayo, have you been able to quantify how much this is going to aid you in the future if you have to roll out additional applications?
Oh, yeah. I mean, again, a year ago, I didn't know how we were going to do this. I really just wanted to get one thing up and running and be allowed to do it with PHI. And now we have a platform where the actual challenge is now there's so many more things that we can do. We're actually getting a little ahead of ourselves because now we can spin up these new products and integrate them very, very quickly. I mean, I just want to shout out to Dhananjay too in terms of what they were doing, and a shout out to Terraform. I mean, the infrastructure as code made a lot of this also possible. And as Google Cloud keeps innovating, they keep making more and more things automatic so that they don't have to be done in the console too. That's one thing we've seen as things develop. But like you guys were working like with one hand behind your back because they couldn't operate in our environment. So they had to like write Terraform code, test it in their environments, then hand it over to me where I could deploy it in my environment. There's an awful lot of screen sharing going on in the early days. But again, it just was an enormous amount of like work that occurred between the teams. It was a very small number of teams, basically, at most like 3 or 4 of us at the time.
Yeah, and that's part of the key to what we've put together with our security foundation at Google Cloud, whether your deployment model is infrastructure modernization, whether it's app modernization, such as what Mayo Clinic did to roll out this new application platform, whether it's data analytics, AI. We want to be able to provide a baseline of capabilities, Terraform blueprints and reference architecture guidance, and additional services to be able to have a partnership to be able to advance your security posture and ultimately help your business agility. So, John, can you tell me a little bit more what the future holds and what the future direction holds with Mayo?
Yeah, so for our products now, we've moved beyond developing our products already. Now we're working towards medical record integration, direct medical integration. We've also started down a path towards getting some of our products certified for use outside of Mayo Clinic. So we were already well beyond sort of our roadmap. Our roadmap, again, a year ago was just to get a product up and running, but now we've got a whole ecosystem up and running. So now we're looking to get this stuff commercialized even outside of Mayo.
No, that's awesome, and that's ultimate business agility from not knowing, trying to get out one product in a year to be able to now commercialize it outside of Mayo. I mean, that I'm glad that we've been able to help drive that outcome. So, awesome. So next we're going to open things up and be able to have some Q&A from the audience. I'll hand it over to Adrian.
Thank you. That was cool, right? Maybe a hand for the friends. All right, so how do we get started, right? How do I get this stuff? Like, how do I get this wizardry that they're talking about? Like, I want to get some of this. So the first thing is we have a lot of stuff to give out, and starting by getting a good foundation. So the basics. We have a really nice white paper that is written by a lot of very, very smart security folks or individuals here at Google that you can get access to. It's a Security Foundation white paper that talks about a lot of things. It's not about just products. It talks about things like billing, operations, security operations, incident response, that sort of thing. Next is, let's talk about the right security use case, right, or the use case. We have, as you know, with Google, you have a lot of support from your account teams, for example. They can help you figure out what type of use case are you thinking, but it will map out, we're going to help you map that out to what are the security outcomes that you want to get out of it. One outcome, for example, is compliance, right? Or we can talk about like, we care about like my PHI data or some sort of things like that. Like what are your security goals and how can you map those out directly? The other, and for that we have a list of, we have a blueprint, we have a Terraform scripts, we have a repository that it's ever growing, and we're creating assets as we understand new security use cases based on our research and work with other customers. The last one is best practices. I don't know, have any of you been in our Cloud Security Best Practices Center? All right, no. So there you go. Our Security Best Practices Center is just that. It's an aggregation of a lot of things that are coming out from a security that you can quickly implement in your environment. As I said, security AI, right? I know it's a hot topic. Everybody wants to build a model. You saw the keynote this morning. Everything's about AI. Well, here are some of the things and risks that we understand that are happening if you build AI capabilities in the cloud. So here's some of the best practices that we've seen, so you're not, caught off guard, or at least understand what you need to be doing, which is security AI here. The security AI workbench is a really cool feature that you can also look into. It can help you to, the AI workbench it's a tool that you can help increment or accelerate your security functions. So far, we've been talking about how can I secure, or how can I run my cloud securely. The AI workbench, it's a tool that is, you probably heard about it, and if not, there's going to be a few sessions today that talk about how to use it. And it uses SecPalm and some of our intelligence, and it also helps you figure out how we as Google build LLMs and basically AI models to help out answer quick questions around security. So for example, this workbench will contain information from our threat intel, and then I can just very easily ask this type of models, hey, can you tell me what are my critical alerts in my high value assets? Well, this is what the security AI workbench is going to help you. So it's a slightly different from the talk track today, which is let me secure your cloud, but the AI workbench is more geared towards the security-specific functions. And last but not least, we want to be with you and try to help you throughout your entire, journey at Google. So the security and resilience framework, we created we call it the Solution Center, which is a number of assessments that you can make, and it's a free tool that everybody can use. You can answer a few questions, and we will be able to provide you with a brief overview of what are some of what's the maturity level, based on your answers, what's the security maturity level that we assess against our best practices and recommendations. And obviously, we will give you pointers to what is the next step. What do you need to do next to get to that, either satisfy that requirement or increment my maturity level to a higher level, right? We think about industry benchmarks and things like that. So that QR code in there, if you already scanned it, is going to take you to that Solution Center. We're constantly adding more stuff, so you can leverage this platform. Again, it's free of cost. There's no cost to it. But now I think so far, again, just to close out and before I move on to Q&A, we want to make sure we want to be with you end to end. We want to help you envision your cloud workloads. You work with your account teams on that. We want to help you secure them and give you recommendations of what's needed. Because there's nothing worse. I've been working in cloud security for a while now, and there's nothing worse to be brought into a conversation when I have to justify a security department that, why are you guys thinking about putting a data warehouse with PII data in the cloud? Wait a minute, so we need to backtrack and start, building everything from scratch and start, proving that the cloud is secure. What we're trying to do is to remove that. We want to try to give you all the confidence that you're building your cloud workloads securely.